Hi, Assalamualaikum and good evening to all. The purpose for this recording video is for PBL assignment under subject BEKC3543 microprocessor. So our topic for this project is high-speed fan. So first, let me introduce our team members. First is the idealist is Adam bin Muda. Second is circuit designer Shafi Narzik bin Mat Said. Third is programmer is myself Muhammad Zamri bin Azman. And the fourth is realist Muhammad Luzman Hasif bin Mazlan. So the project objectives is for this project, the high speed fan project. We present has three distinct speed range that will be simulated by the Easy68K software. So the first objective is to learn the principle, concept and learn to use information in various situations. The second is to fill the gap between theory and practice by engaging students in real-world challenges that allow them to appreciate the value and application of knowledge. The third is able to simulate using Easy68K and integrating your program with the simulator. Fourth, fully understand the simulation and be able to explain the entire project.
We continue with problem statement. There are three of them. The first one is design and develop a microprocessor-based system using the Motorola MC68K. The second one is to enable precise control of a high-speed fan with 3 speed settings. The last problem statement is to incorporate an intuitive user interface with dedicated buttons for on-off control, speed selection, and emergency stop functionality. Next, we move to solution. Okay, so for solution part, we have 3 items, which is software, code, and report. For software, we're using Easy68K software to simulate the project and its hardware to illustrate the project. In terms of coding, we learn assembly language to create program and also to simulating it. In terms of report, we brainstorming and discuss all the possible ideas to design the project. We're running the software and hardware simulation and all of it recorded in the final report.
Based on this flowchart, the simulation will be start. First, check the first switch. When the switch is on, the word hello will be displayed, but the motor still turn off. Second, check the switch 2. When the switch is on, the motor will start at minimum speed and the display will show speed 1. Third, check switch 3. When the switch is on, the motor will change to medium speed and the display will show speed 2. Next, check status 4. When the switch is on, the motor will change to full speed and the display will show speed 3. Finally, check status 5. When the switch is on, the motor will stop completely and the simulation will also stop completely and the display will show the word stop. This like emergency button to prevent any injury or damage when an unexpected thing happen. The simulation and the simulation must be restart to start the program again. Improvement suggestion. First improvement suggestion is installing a buzzer. A buzzer can be used to offer audio feedback and warning to signify different scenario. You could, for example, set the buzzer to ring when a button is hit or when the fan speed change. This is very helpful for delivering user feedback and notification. Second improvement suggestion is installing a heat sensor. Combining a heat sensor into the fan system can be allow it to automatically adjust the fan speed based on the surrounding temperature. This can provide a more efficient speed The heat sensor can be measured, the temperature and speed signal. To be fan control, you need to adjust the speed accordingly.
Assalamualaikum. My name is Shafiq Nur Haziq. Here an explanation of the provided 68K assembly code. First, the code starts with the declaration part where memory addresses are designed to various variables such as switch, LED and 7-segment display. Second, from the line 25 to 28, initial conditions are assigned to several data register from D0 to D5 and the main loop begins. In the main loop, the code continuously check the state of switch and perform different action based on its value. If switch match the value in D1, the code jumps to the startup subroutine, which display the pattern halo on the 7-segment display. If switch match the value in D2, the code jumps to the speed 1 subroutine, which rotates the LED value and display a specific pattern on the 7-segment display. Similarly, if switch matches the value in D3, D4 and D5, the code jumps to the speed 2, 3 or stop subroutine respectively, performing different action and displaying pattern on the 7-segment display. The stop subroutine blink the LED and display a specific pattern on the 7-segment display. The code includes delay subroutine, speed, fast, faster, fastest that introduce delay by looping until a certain condition is met. This subroutine control the speed of LED rotation. The code ends with the end directive. Next, here the simulation of hardware. Okay, thank you.